For at least one of the labs, you will have to plot quantities to find a power law dependence. And I'd like to review a simple straight line, but with the log-log coordinates so that you can see how easily this can be done. So let's begin with, I hope, a good memory you have from algebra somewhere along the way of y equals mx plus b, the equation of a straight line. Plotted x versus y. M is the slope. B is the y-intercept. So where does it intercept the 0 point of x? Let's take a look at b first before we come back to m. We're not going to need b actually, but we'll just mention it. If I set, this is really, I could write this function as y of x, if you remember. And if I set x equals 0, y of 0, I come up to this equation. I set x equal to 0 equals m times 0 plus b. And so that, of course, is 0. And so y at 0 equals b. And so b is the definition of the y-intercept. What about the slope, though? What about m? M, I hope you remember, the rise, how big is it climbing compared to how big is it moving along the x-axis? So delta typically means a change, the Greek letter delta. So we may write this as, let's pick 2 points, cleverly picking them as 2 and 1. So this is y2 minus y1 over x2 minus x1. And let's see, in fact, if that equals m. Up at the top, you might remember that our equation for y is mx plus b. So we have y2, the m hasn't changed, m times y2, whoops, that's not y, of course, it's mx plus b. x2, y equals mx plus b, b is a constant, that's y2 minus mx1 plus b over simply x2 minus x1. Well, look what we have here. We have a b over here, and we have a b over here, and so they cancel because of this minus sign, which I've lost in my circles, right? So what does this equal? This equals mx2 minus mx1 over x2 minus x1. We factor the m out of the numerator, m x2 minus x1. We have x2 minus x1 in the denominator. See, I got it right that time. These guys cancel out. So we have, in fact, established, you may think it's a little silly, that m equals m. But remember where we started, back up here, what we did was we took just this definition, the change in y over the change in x, and we put it into the two expressions for y, 2 arbitrary points that we've chosen. And in fact, we got the right answer. We showed that it's true. So we can have some confidence that this equation that we've written over here, let's put that in a box too. Y equals mx plus b is correct. The m appears to give us the slope correctly, and the b gives us the intercept. Now, suppose, though, instead of just regular linear coordinates, suppose we had what's called a power law. So, in fact, then what we have is y equals some constant, cleverly, let's call it a, x to m, where m now is the power. It's not the slope anymore. Let's take the logarithm of both sides. Log of y, you'll have to remember how to take logarithms, equals log of ax to the m. Now, when you multiply 2 numbers together and take the log is the sum, because the log is just the exponent. So this is log a plus log x to the m. And again, I hope you remember with logarithms, if you don't, it's all right, because you don't have to do this as much as be able to do just the end result, because it's the logarithm is the exponent. When I have the power raised to the exponent, that just comes out. So this is log a, it's a factor, plus m log x. All right. So log a, that's just the logarithm of a constant. That's another constant, right? So let's call that, let's be clever. Let's call that b. All right. Log x, the logarithm is a fixed function, right? We take the function, it's the same function all the time. X varies. In fact, if we want to be clever, right, we could say that log of x is a function, f of x equals log of x. And you plug in the x. You remember how functions work. You plug in the x, and you get an f. That's all the logarithm is doing for us. And so let's be clever again and call this x prime. All right. And we've called that b. So what? Look how we've changed the equation. Oh, we forgot about logarithm of y. Let's write that on the left-hand side. Log y over here. And let's call this cleverly, you guessed it, let's call this y prime. And now look at the equation we have. We have y prime equals m x prime plus b. And remember that our m over here goes all the way up to here. It's that power law. So if I plot y versus x, we don't have to tell anyone that it's really x prime and y prime. I plot y versus x, and I pull a power. I find out m, the slope. What I've plotted when I've plotted y prime, remember, is y prime was equal to log of y. Okay? And x prime was equal to log of x. So what's the point? The point is that if I plot the logarithm of y against the logarithm of x, and I get a straight line, the slope of that straight line is m, and that m comes all the way up here, is our power. So if I have two quantities that are related in power law, look at this, y equals ax to the m. For example, one might think of Kepler's law, right? We have that p squared, the period squared, if we're in astronomical units, is a cubed. So we might say that p equals a to the 3/2. Right? That's the sort of thing we're doing. P is y. That's our y. That's our m. And that's our x. Okay? Obviously, if you have any questions about this, I'm available on Slack, and so your classmates, and you can certainly raise the questions in the synchronous sessions as well. Thank you.